Okay, so in this video I will show you how to find the intervals on which a function is increasing and decreasing, how to find the local max and min, how to find the intervals of concavity, and how to find the inflection points. So we start by finding f prime of x. I already found this, so it's just going to simplify quotient rule. Just use quotient rule to get the answer, and it's going to simplify to this. It's also good to note that x has to be bigger than 0. So then we find the critical numbers, which are here. Well, a critical number is basically whatever makes the function undefined or whatever makes the function equal to 0. So if we plug in 0 here, then it's undefined. And if we plug in e to the power of 2 here, for x, then it's the answer will be 0. So these are the two numbers, but this 0 is not in the domain, so we're just going to cross that out. We're just going to use the e squared. So we draw a number line, put e squared here, and then we try out a point to the left and to the right. So let's just try out 1. So 2 minus ln of 1 over 2 times 1 times root 1 equals 1. So that's a positive number, so we can say the graph is going up. And then e squared is basically 7.38. So we're just going to use 8 on the other side. Just any number that's bigger than this number is fine. So 2 minus ln 8 over 2 times 8 times root 8. And this number is smaller than 0. And then we have found the intervals. So we can say increasing, and then we just do infinity to e squared, decreasing as e squared to infinity. One thing to note is if there were many intervals, you just write it as just write this and then a, b, and then this c, d, you just use it like that. Okay, let's just delete that. Okay, now we're going to find the max and min. So, well, you can just use this as your max and min pointer, because if the function goes up and it goes down, then this has to be your max or min. So then we know that we have a local max at e squared, and you're in Calc 1, so you should probably be allowed to just say f of e squared if you don't have to use this point. Alternatively, you just plug it in. So 2 minus ln ln of 2 over root 2 equals 0.4901, and then so that's your point. So then we're going to find the intervals of concavity and inflection points. To do this, we should just find f double prime of x. I already found that, so that's just going to equal to, so you just differentiate this function here one more time. So f double prime of x is 3 ln x minus 8 over 4x squared root x. And once we have this, we find the critical numbers again. And what will make this function undefined or equal to 0? So it's going to be 0, of course, but again, we're not going to use 0 because it's not in the domain. And then what makes the top equal to 0? That would be e to the power of 8 over 3. So we keep going. We draw our number line. Oops, it's a bad line. Okay, something like that. Have our point e to the power of 8 over 3, which is actually equal to, let's say, about 14.4. So I'm just going to use, let's say, 2 on the other side, because it doesn't matter what number you use. So 3 ln 2 minus 8 over 4 times 2 squared times root 2, and that's equal to a negative number. So you just write that there, which basically means that it's decreasing on this side. And then you just use a bigger number, so you do 3 ln, let's say, 15 minus 8 over 4 times 15 squared times root 15. That's bigger than 0. So it goes like this. So then we know function is concave up on negative infinity, concave down first on negative infinity to e to the power of 8 over 3, and concave up on e to the power of 8 over 3 to infinity. Make sure you have round brackets, because we're not including the actual point. It just gets a bit complicated with that. And then finally we want to find the inflection point, and the inflection point is just when just the point, like when the function changes. Like this is not the function, but this is concave up here, this is concave down, so this is like right here is the point where it's changing, so this would be the inflection point. And we can see based on this thing that the inflection point is going to be right here. So the inflection point would just be e to the power of 8 over 3 and f of e to the power of 8 over 3. Make sure that this is f, so if you actually plug in the value, you're not going to plug it into this one, into f double prime. You're going to plug it into the original function. And well, okay, so this is basically how you do it. There's also one more one extra thing you could do. Sometimes on tests they won't give you exact numbers, so you have to do this extra thing. So if you want to see if this function, where the max is, so where the max is, we had this point, or if you want to know is this a max or min, you can just plug it into f double prime. So you could just do f double prime of e squared equals, and then we're just going to put that in. So that's just 3 ln e to the power of 2 minus 8 over 4 times e to the power of 2 squared times root of e to the power of 2, and that is a negative value. It's negative 3.36 times 10 to the power of negative 3, which is smaller than 0, which basically means it's going like this, which tells us that it's a max. So that's a different way how you find the max. You can either look at this thing and then see, okay, it's going like this. Sometimes on a test you have to use this thing, and then you just plug in the critical value from the increasing and decreasing, and then you just see if it's positive or negative, and that's how you find everything.